Hello dear students, all of you welcome to Vidyayana classes. Today we will discuss some expected board questions on increasing functions and decreasing functions. First question, show that 2 sin x plus tan x greater than 3x for all x belongs to open bracket 0 to pi by 2. Answer, let fx is equal to 2 sin x plus tan x minus 3x. Differentiating both sides with respect to x. Derivative of x with respect to x, that is f dash x, 2 cos x. Derivative tan x, say square x. Derivative minus 3x, that is the minus 3. Clear? For all x belongs to open bracket 0 to pi by 2, let a is equal to cos x greater than 0. For all x belongs to 0 to pi by 2, cos x is greater than 0. B, cos x greater than 0. C is equal to c square x greater than 0. For all x belongs to open bracket 0 to pi by 2. Clear? A greater than 0, B greater than 0 and C greater than 0. Clear? Since A equal to B not equal to C implies AM greater than GM. Since A equal to B but not equal to C, arithmetic mean is greater than geometry mean. What is the arithmetic mean of ABC? That is A plus B plus C divided by 3. What is the geometry mean of ABC? Cube root of ABC. Clear? Arithmetic mean is greater than geometry mean. What is the value of A? Which implies cos x plus cos x plus c square x divided by 3 greater than cos x into cos x into c square x whole to the power 1 by 3. Clear? Which implies 2 cos x plus c square x divided by 3 greater than cos square x into c square x, that is 1. Cube root of 1 is 1. Clear? Which implies 2 cos x plus c square x greater than 3. Which implies 2 cos x plus c square x minus 3 greater than 0. 2 cos x plus c square x minus 3. This value is f dash x. F dash x is equal to this, which implies f dash x greater than 0. That implies fx is straightly increasing on open bracket 0 to pi by 2. Clear? Clear? Okay. X belongs to open bracket 0 to pi by 2. That implies x greater than 0, less than pi by 2. Which implies this x greater than 0. Which implies this fx greater than f0. Clear? Since f is an increasing function on 0 to pi by 2. For x greater than 0 less than pi by 2, fx is greater than f0. Since fx is an increasing function, what is the value of fx? Fx means 2 sin x plus tan x minus 3x greater than 0. Since fx is equal to 2 sin x plus tan x minus 3x, f0 is equal to 2 sin 0 0 tan 0 0 minus 3 into 0, that is 0. So f0 is 0. Clear? Which implies this 2 sin x plus tan x greater than 3x for all x belongs to open bracket 0 to pi by 2. Hence proved. Hence proved. Clear? Clear? Okay. Next question. What is the sub interval of open bracket 0 to pi for which the function sin x plus pi by 4 is increasing what is the subinterval of open bracket 0 pi for which the function sin x plus pi by 4 is increasing. Clear? Answer. Let fx is equal to sin x plus pi by 4. At x equal to 0, x equal to 0, y equal to fx, y is equal to sin 45 degree, that is equal to 1 by root 2. X is equal to pi by 4, y is equal to 1, x equal to 3 pi by 4, y is equal to sin pi, that is 0, x is equal to pi, y is equal to sin pi plus theta, that is minus sin theta minus 1 by root 2. At x equal to 0, y is equal to 0, y is equal to 1 by root 2. At x equal to pi by 4, y is equal to 1. At 3 pi by 4, y is 0. At pi, at x is equal to pi, y is minus 1 by root 2. X is equal to 3 pi by 4, or x coordinate 3 pi by 4, y coordinate is 0. From this figure, it is clear that from 0 to pi by 4, the function is increasing, then decreases up to pi. Clear? The function increases from 0 to pi by 4. F increases in 0 to pi by 4. What is the subinterval of 0 to pi, open bracket, for which the function is sin x plus pi by 4 is increasing. So the answer is 0, open bracket, 0 to pi by 4. In this interval, the function is increasing. Therefore, f is increasing on 0 to pi by 4, which is the subset of 0 to pi. Clear? Clear? Also, we can solve this question by the derivative method. Clear? Second method. Let fx is equal to sin x plus pi by 4. X belongs to open bracket 0 to pi. Differentiating both the sides with respect to x, which implies f dash x is equal to cos x plus pi by 4. Put f dash x equal to 0, which implies cos x plus pi by 4 is equal to 0, which implies x plus pi by 4 is equal to 2n plus 1 into pi by 2, n belongs to z. Z means set of integers. Cos x is equal to 0, x is equal to 2n plus 1 into pi by 2. N belongs to Z set. For n is equal to 0 implies x is equal to pi by 2 minus pi by 4, which is equal to pi by 4. For n equal to 0, the right hand side is pi by 2. So x is equal to pi by 2 minus pi by 4, that is equal to pi by 4. For n is equal to 1 implies x is equal to 3 pi by 2 minus pi by 4, which is equal to 5 pi by 4. 6 minus pi, that 5 pi by 4, not belongs to open bracket 0 to pi. So there exists only one critical point. That means derivative at x equal to pi by 4 is 0. It is 0, it is pi by 4 and it is pi. For x greater than 0 less than pi by 4, f dash x is equal to cos x plus, if x greater than 0 less than pi by 4, f dash x is greater than 0. In this interval, f dash x greater than 0. So the neighboring interval will be less than 0. X greater than pi less than pi by 4 less than pi implies f dash x less than 0. So in this interval, the function is increasing. Therefore, 0 open bracket 0 to pi by 4 is the sub interval of open bracket 0 pi, so that sin x plus pi by 4 is increasing. In this interval, the function is increasing. Clear? Clear? Okay. Next question. Test the monotony of fx is equal to a to the x, where a greater than 0, a not equal to 1, x belongs to R. Test the monotony of fx equal to a to the x, where a greater than 0, a not equal to 1, x belongs to R. Monotony means either increasing or decreasing. Answer: fx is equal to a to the x. Differentiating both the sides with respect to x implies f dash x is equal to a to the x ln a, or a to the x log a with base e. It is the graph of y is equal to log a base e. 1 0. This point is 1 0. For all x belongs to R, that is real set, a to the x greater than 0. That means exponential function is always positive. From 0 to 1, the logarithm value is negative. Above greater than 1, the logarithm value is positive. When a greater than 0 less than 1, the value is negative. For a greater than 1, the value is positive. Clear? Case 1. Let a greater than 0 less than 1. A greater than 0, a not equal to 1. Implies log a base e is negative. In this interval, log a base e is negative. So f dash x is equal to a to the x log a base e. A to the x is always positive. Log a base e is negative. So the result is negative. Implies f dash x less than 0. Therefore, f is strictly decreasing for all x belongs to R. R means minus infinity to plus infinity. When a greater than 0, less than 1. Clear? Case 2. Let a greater than 1. For a greater than 1, the value of logarithm function, that is log a base e, is positive. Implies log a base e greater than 0. F dash x is equal to a to the x log a with base e. A to the x, that means exponential function, is always positive for all x belongs to R. And log a with base e negative. So the result is positive, sorry. It is positive, it is also positive, greater than 0. F dash x greater than 0. Therefore, f is strictly increasing for all x belongs to R or minus infinity to plus infinity. That is real set. When a greater than 1. Clear? Next question. Find the subinterval of open bracket minus pi by 2 to pi by 2 in which fx equal to tan x minus 4x is increasing and decreasing. Answer. Fx is equal to tan x minus 4x. Differentiating both the sides with respect to x implies f dash x is equal to x square x minus 4. Put function is increasing means f dash x greater than 0. Function is decreasing means f dash x less than 0. Put f dash x equal to 0. The point at which the derivative is 0, its neighboring interval, the derivative is greater than 0 or less than 0. So put f dash x equal to 0, which implies x square x minus 4 is equal to 0. 1 minus 4 cos square x is equal to 0, which implies 4 cos square x is equal to 1, which implies cos square x is equal to 1 by 4, which implies cos x is equal to positive of 1 by 2. Since x belongs to open bracket minus pi by 2 to plus pi by 2. In this interval, cos x is always positive. Clear? Cos x is equal to 0. Cos x is equal to half, which is same as cos pi by 3. Cos 60 degree is equal to half, which implies x is equal to 2n pi plus or minus pi by 3. Since cos x is equal to cos alpha, x is equal to 2n pi plus or minus alpha. N belongs to z set. Clear? N belongs to z set. That is set up of integers. For n is equal to 0 implies x equal to plus or minus pi by 3, which belongs to minus pi by 2 to plus pi by 2. So it is true. For n is equal to 1, x is equal to 2 pi plus or minus pi by 3 is false. Since 2 pi plus or minus pi by 3 does not belongs to this interval. So there exist two critical points, that is pi by 3 and minus pi by 3. So that the derivative is 0. Clear? It is 0, it is pi by 3 and it is pi by 2. It is minus pi by 3 and it is minus pi by 2. At this point and this point, the derivative is equal to 0. We have to test in this interval, in this interval and in this interval. For x greater than minus pi by 3 less than plus pi by 3 implies f dash x. In this interval, the derivative, for example, x equal to 0, it is negative. So all values are negative. So f dash x less than 0. F dash x is negative from minus pi by 3 to pi by 3. For x greater than pi by 3 less than plus pi by 2, f dash x is positive. For x greater than minus pi by 2 less than minus pi by 3, f dash x greater than 0. In this interval, the function is decreasing. In this interval, the function is increasing. In this interval, the function is increasing. At pi by 3 and minus pi by 3, the function, that is the derivative of fx, vanishes. Clear? Therefore, the function is increasing for x belongs to minus pi by 2 to minus pi by 3. Open interval. Union open bracket minus pi by 3 to pi by 3 and decreasing for x belongs to minus pi by 3 to pi by 3. Clear? Next question. Test the monotony of the function fx is equal to log x base a greater than 0, a not equal to 1, x greater than 0. Test the monotony. Monotony means either increasing or decreasing. The function is increasing, implies is f dash x greater than 0. The function is decreasing, f dash x less than 0. Answer: fx is equal to log x with base a greater than 0, a not equal to 1 and x greater than 0. Implies this. Differentiating both the sides with respect to x, f dash x is equal to 1 divided by x ln a or 1 divided by x into log of a base e. Clear? Okay. Case 1. Let a greater than 0 less than 1. It is the graph of y is equal to log a with base e. A equal to 1, the value is 0. It is the graph of logarithm function log a with base e. F dash x is equal to 1 by x log a base e. A greater than 0 less than 1. A greater than 0 less than 1. a greater than 0 less than 1 log a with base e is negative. Clear? For a greater than 0 less than 1 log a with base e less than 0. X is always positive. X always positive. Log a base e for a greater than 0 less than 1 log a with base e is negative, positive and negative. Result will be negative. Which implies this f dash x less than 0 implies this f is decreasing on 0 to infinity when a greater than 0 less than 1. Clear? Clear? Okay. Case 2. A greater than 1. F dash x is equal to 1 divided by x into log a. For a greater than 1. For a greater than 1 log a base e implies s. Log a base e is greater than 0. X is greater than 0. X is greater than 0. Log a base e is also greater than 0. So the result will be greater than 0. Implies s f dash x greater than 0. Therefore, f is increasing on open bracket 0 to infinity when a greater than 1. Clear? Clear? F is decreasing on 0 to infinity when a greater than 0 less than 1. F is increasing on 0 to infinity when a greater than 1. Clear? Okay.